Hello and welcome back to the Hyperthesis podcast. We are here in the final episode of the season, which we decided probably a week or two ago that this is gonna be the last episode because we weren't sure. Actually, this is gonna be the one of the most one of the busiest times of the year when the semesters at school start. So we're gonna be assigned to work and whatnot, to do more work in terms of teaching assistants. So we're gonna take some time off around a month or so before we come back and to first to review and reflect what went well, what went wrong. But for today, we're gonna be more talking about our journey and who we are. I noticed that we haven't really talked about ourselves or introduced in terms of our story and who we are at all. So, as the last episode is gonna be about us, it's gonna be very spontaneous because usually we have a little note we do every time. What are we gonna talk about? But today is pretty much a blank slate. So let's see how that goes. My name is Feely.
Hi, everyone. I'm Patrick.
I'm Liam.
So today I like to talk about our personal journey and why do we become physicists or scientists and how we view the world. Basically, I think I can start. I'm in well, it sounds strange now to say that I'm in a foreign country because I've been here. I think almost 6-7 years now. It is a long time because I'm not that old. I'm in my mid 20s, and 7 year is a third of just quite a significant amount of your life that if you don't count childhood, which you don't recognize or remember much anyway. So let's say that's almost half of my contemplating life that I've spent here, and it's been quite a journey.
How have you enjoyed your time here? What are some big differences that you've noticed over the years? Snow being probably a very obvious one.
Yeah, well, I couldn't say I had never seen snow before because I had when I was like very young when my family went to I think Germany and some other country, and I may have seen snow, but never in that capacity in Nova Scotia, which is literally like you think, oh my god, you like snow, and then it never stops snowing, and you start to realize it's like, well, this is a lot of work shoveling snow and stuff. But in terms of science, back home, people are more concerned about the amount of science you need to learn. You have to learn a lot. And to me, that's not very helpful intellectually. And it's not very healthy either, intellectually and mentally. There are people who hate science because of that. But luckily, I had a very good high school teacher who was actually had a physics degree. And he kind of showed me that to me, physics is like a bridge, not really a bridge, but a compromise between philosophy and mathematics. I liked mathematics, but I don't like proving stuff all the time. I like philosophy, but I don't like how the structure of writing it is it's not the most um in your face or direct things. That physics is more like, well, you can do some um physics or the philosophy stuff ish with to talk about the world, but in a rigorous mathematic way.
Yeah, it's a very kind of old school train of thought that science is just memorizing a bunch of things. And it does involve a lot of memorization, but it's not the point. The point is that you learn to solve problems in kind of a really in a nicer way, and you get better at kind of looking at a problem and being like, okay, here's some strategies I can take to overcome it.
Yeah, I remember having to study like 10 subjects a semester in school because like you can it's not like high school there. It wasn't like here where you can choose your classes. Well, from 1 to 12 there's the certain at the time when I was there was determined for you. except for high school, you can choose like art, art centric or science centric. But I still had to learn all the high school like history, biology, or like every subject, English, also Thai, my language, like all the subjects at once. So it was a lot of work, and you know, I excel pretty well in school. I think most of us who came to do like PhD or higher education did really well in like a primary or secondary school.
Yeah. Like in Nova Scotia, where I grew up at least, you don't really choose courses until grade 9 or 10. For me, it was grade 10. And there's like a certain amount of requirements you have, but it's definitely a lot more freedom than just having your classes chosen. Like I chose to take, biology in both grade 11 and 12, and chemistry and physics, and all these different sciences, but there was definitely a few classes I avoided taking. I didn't There was a class on oceans which I didn't take, which I think it would have been a fun class, but I was just struggling through chemistry, biology, calculus, and physics, so I was like, yeah, I don't really care too much about the oceans, although I think that'd be a really cool class.
And back home, there's this cram school culture, which I don't see here, where you finish your normal school, right? And during the weekend, you go to other like tutoring school. And it was really common because there are standardized exams were really competitive. I know they have a lot of cram school in like Japan and Korea, China, like a lot in Asia has that part of culture. So I spent a lot of time in those in middle school and introduced me to like a higher advanced level of, well, now in retrospect, it's not advanced, but in terms of problem solving, there are complicated problems and really creative problem solving, um, but not in terms of material. So they introduced me to a pretty much a difficult version of solving like problems in physics and mathematics, even chemistry, biology. And I at the time I really liked it, but I also hated the the execution of it. I believed, I still do, that people should just go to normal school and have proper education, don't have to pay other people like the private company so that you can pass standardized exam. To me, that's ridiculous. So in high school, I told my parents like I'm not going any cram school. I put my foot down, and maybe I should have, but I think I did pretty well because I realized I just had to learn in class, read some books. It should be fine. But there are a large advantage for people who go to cram school in terms of like, it's not the pure, well, nothing is all, flowers and rainbows. There's a lot of corruption going on in terms of like people who make exams and stuff. So yeah.
Yeah, standardized tests are a tough one because, like, overall, on average, they kind of raise the education level of your population, I guess. Because, if everyone has to pass them to move on, then slowly over time, I think people will learn more. But at the same time, you can't judge someone's intelligence by like a test. Like, a lot of people don't test well. People learn certain ways. People do things in different ways. Like, I'm very much so. I can't do a lot in my head. Like, I suck at mental math, but like anytime I have like paper in front of me and a pencil or a computer, I'm quite good. I'm very good at writing things down and keeping my thoughts down. But so I have all these like lists everywhere of like I have like 5 different to-do lists for different categories of things, and anytime I work, I have to write stuff down. I'm not great at doing things in my head, right? And I happen to test well. At least when it's a written test, but if it's like someone speaking to me, I'm not good at oral tests, for example.
Yeah, it was interesting speaking about standardized exams. So I went to high school in Alberta, and back then they had a provincial wide standardized test in your grade 12 year. So it was worth 50% of your final grade. I don't know how that compares to other places. I know some schools in Germany have like 100% final that's worth everything. But even having a 50% final that decided if you essentially passed or didn't pass, or if you got into university, it was really interesting. And it definitely did bring up the standard of education. So going from Alberta to Nova Scotia, there's definitely a change in their education systems and also a change in the standards from what I saw, especially even entrance standards to universities. But the fact that there was a standardized test, I know a lot of people who didn't perform as well because, unlike, for example, Liam, they don't test well. They're very good students, they just don't test well. And so, yeah, I have a lot of thoughts about standardized tests, but
It depends on how you do it too. Here, standard like if I look at SAT and stuff, like those are easy questions, right? If you understand the topic a bit, you're like the decent amount, you should be able to solve those problems. The problem with standardized exam at home is they pick like what the most difficult problems in each topic and add more difficulty to it and just make everyone take it. And that doesn't work. Like the national average, I think my year, if I remember correctly, was 18 out of 300 in math. So 6%. That's that can't be right? Like nobody should like the average shouldn't be 6%. Like it's to me that is ridiculous. So there's a problem with people who actually wrote those problems.
Yeah, that's brutal. And that's I feel like that's just a bad way to do things. Yeah, as a people in academia who've been in it for so long, I feel like we all have very strong opinions about teaching and testing and whatnot. And if you're the point of a test is to make sure you understand the material you learned in the class, right? Like there's I hate it. I hate it when you get a test and they just give you like this super hard problem, and it's like, okay, like I understand how stuff works in the class, but you've given me this very niche problem that requires like a very specific train of thought to solve. This doesn't really test like my knowledge on the course material at all. It just tests if I'm like good at noticing like one tiny key feature. So I always find that so annoying.
Yeah, when I was in the camp for prepare for like physics Olympiad and stuff, they say like the very hard problems are the problems that only have one or two ways to solve it, and you have to see it. And if you don't see it, you just can't solve it. Like there's some mathematics problem, like geometry problem, where you have to draw certain lines and connect them to actually see the solutions come out. If you don't know that you need to draw those lines, or you don't have that creative mind, you can't solve those problems. It's ridiculous.
that was something that I guess annoyed me about our physics education too, is some classes were very nice and you could figure things out different ways. But some exams that we had in our physics degree, it was, okay, you need to use this certain trick. If you don't know about this trick or forgot about it for whatever reason, then you can't answer the question. I remember the one that stands out in my mind, I believe, was in electromagnetism, where you needed to know what this specific integral simplified to be able to solve the question. And at this point, we were allowed to use Mathematica, an online, or I guess a computer-based analytical software, and that didn't account for the simplification. So you need to first identify which problem the simplification was for, and then implement it at the right step and recognize it, which was a little bit frustrating.
Yeah, I found the exact same thing with electromagnetism as a course. I found it way more difficult than all the other courses for some reason, and it always felt like there was never like it always felt like the solution to every type of problem you did was some weird like one-off thing that you only do once in the entire course. They'd be like, "Oh, well, you see, you have to do this specific transformation to solve it." And I'd be like, "We've never done that, and we will never do it again." It's just like one of those problems that you have to do it in order to understand it.
Yeah, I think there's those conceptual course, which is nice. I like, and there are those recipe book course like E&M or PDEs, partial differential equations, where you need to memorize like multiple ways to approach problems and stuff, which I don't mind that much, but I don't find it's very stimulating intellectually. And the thing is, like when I came here, like my first year was like apart from like English and philosophy courses, the science and math course was like a cruise. It was so easy because the tests were meant to basically test your knowledge and your understanding of the material, not your creative problem solvings. And that I think that's good because at the end of the day, you should just, it's first year undergraduate. You should just understand the material. If you understand it, let it cooks in your mind for like a year, you start to see way to utilize it to solve problems. So in my mind, like, even though it was easy, it helped reaffirm my understanding, my fundamental understanding of like science and physics.
Yeah, there's the Griffiths textbooks, specifically the quantum mechanics one. I think they do this thing where each problem has 1, 2, or 3 stars next to it, and one is like I forget what he calls it, but one is like the fundamental problems you should do in order to understand the topic. 2 is like the slightly harder ones, but they're quite useful to go through. And 3 are like these niche problems, the ones that require maybe like multiple days to solve and are extra hard. And you're not, he says it'd be great to go through them, but if you're going to go through some of them, go through the 1 and 2 stars first. And so those 3-star problems are the ones I always think should be kind of assignment problems, because you have to do these kind of one-off things every now and then, but the overall theme of it is quantum. Like for the Griffiths quantum mechanics textbook, a 3-star problem, you'd have to apply many different things you've learned in this one problem, and I really liked that. My high school physics teacher was really good at assignments that had kind of like creative problem solving in it, but still teaching you at the same time. And then the tests he gave were kind of more the basic, like you should know this. This is like the basic stuff from the course you need, not these weird problems that are very hard to solve, especially when you're under stress.
Yeah, I think another point I like to raise is about scientific curiosity too. I feel like a lot of scientists, especially physicists, we are deeply curious about the world. And to me, it I was always curious, but was never really thought about it that much until I read this book by Richard Feynman. Is Surely You're Joking by Mr. Feynman. It's like a bunch of anecdotes and short stories that was told by um, Richard Feynman, who was a famous physicist back in the days. He was part of the Manhattan Project for the nuclear bomb. And if you study physics, the Feynman diagram or the multiple ways he solved integrals and whatnot. To me, it just help kind of cement those curiosity and what it is, why we are curious about the world and why we ask a lot of questions. I read that book in one sitting. I sat down, probably one of the first English books I have read, and it was easy, right? It was, written in general public language, and you start to learn about how he fixed radio growing up, and you start to draw some similarities to your life and how you think about the world as a whole and why you're so curious, why you want to study physics, why you want to study science.
So that brings up, I think, a good question for all of us is what motivated us to study sciences? So what motivated all of us to start a bachelor's degree in physics or just really any science?
Yeah, because, well, back home, physics degree is not really known. We call it like a science degree are not really popular. So it's strange. So at the time, the notion was that people who fail to get into engineering and medical school, because we go to medical school right after high school, they would go to pure science, which is like physics, chemistry, biology. So that was the notion, the thought of when the people think about physics or science degree, and here is completely different. When I found out that in the West or in other places, not just the West, like the science degree actually means something. They actually have a career for it. That's when I start looking more into it. And I found out when I actually came here that the doors of opportunities are very large. A lot of people who take physics or pure science can work in many fields. They can even go in doing masters and PhD in engineering if they want to. So it actually helped open my mind because I didn't want to be an engineer because I don't know. My father is an engineer. My little brother is now an engineer. I have nothing against engineering, but it just doesn't suit me. It doesn't answer the fundamental question in my mind. It probably make more money. I think it's definitely can make more money, right? But I just simply wasn't interested. Maybe just how I was programmed. It just my nature. But to me, choosing a career has to satisfy the lifelong question I had about the world, which has changed a lot since I learned more about physics, since I like finished undergrad, starting grad school, looking back and see those undergrad knowledge was just so basic, very fundamental. Like we struggled many nights on those concepts, but looking back, those are like the most fundamental concept you have to understand in the field.
Yeah, it's really interesting how a lot of these older problems that were solved a long time ago, they took a lot of work to get through. They're quite complex. Like these, like just think of like geometrical optics problems. There's like a bajillion rays going in every direction, and someone sat down and drew it all out with a ruler and measured all the angles and did all the math. Whereas now it's very much like it's funny because I find like quantum mechanics easier than electromagnetism, but you'd think it would be the opposite, right? I don't know. I find that kind of interesting.
Well, what about you, Patrick? To your own question.
I mean, I guess to answer my own question, much like Feynman, that spark started when I was younger. Um, when I was in, I think, grade 3, I had a really awesome teacher who kind of ignited that spark. And she was very much about the environment and doing as much as we can to protect that. Like, she introduced composters into the school and everything. And just, I think that's where I want to say that's the moment where I became aware of the world. Not because before it was just, oh, my world is school and the house and maybe the pool and just very limited, but that expanded it a lot. And so from there, I started asking questions and really enjoyed science and math. Wasn't the best at math, that is still true, but definitely enjoyed asking questions and trying to find out as many answers as possible to them. And so I think for physics specifically, what ignited that spark was a teacher in grade 5 gave me a book. I'm not sure if anyone has heard of it, but it's A Brief History of Time by Stephen Hawking. Um, I'm sure many people have that sitting on the shelves. I think that's what it's best known for. Um, but that book was like, oh, wow, we have a lot of answers and there's still some things that we don't know. And so I think honestly that drove me to keep studying physics, and that drive helped me survive through some terrible science teachers through high school, especially, where they would yell at me and, yell at the class. And I think it's because of that I went to study physics.
That's really funny you talk about those books because I have two of that book because I got them as gifts, and second person didn't know that I had the first one, and I have them sitting on the shelf, and I still haven't read them yet because I spend all day reading his papers and not his books. But yeah, that's you guys. Well, you seem to have been introduced or interested in physics very very early on. Um, a lot of people I've talked to, they don't kind of realize it till like high school ish, whereas I mean, I don't know about Feely, but like you were thinking of it as early as grade 3 or 5 ish, right?
Not really, but I think I have to give credit to my parents in terms of scientific mind because I remember, what people read growing up, right? I remember my parents had a globe in the house, and to me that was so fascinating to see all different countries on the globe, and they have this book, an atlas. So most of the books we have were like paperback, and that's one of the few hardcover, beautiful like leather bound atlas, pretty thin, but it's just full color, just how they do geography. And to me that was just starts to sparks this explorer side of me. But the one that really kicks it was when parents buy like comics and stuff you when you were young, they bought they bought these where they were basically like a little cartoon books about a kid who got basically time traveled into um, um, some like Babylonian and Mesopotamia stuff, where they start discovering numbers, and they think of this as like so cool. Like the number zero was such a revolution back in the days, and the kids just go around, get to meet Pythagoras, and you learn about the history about Pythagoras theorem and why it's so cool. I was like grade 3, grade 4. I didn't know Pythagorean theorem. I didn't know how significant it was. But as a kid, seeing these, like, oh my god, and like the two side A, B, and C, and it's become to this equation. I didn't know what that equation meant. I had to learn through the comics, and to me, that's such a great way to introduce children to more advanced concepts in mathematics. Like it was so easy too. Like even counting, like why do we have 10? Like what's the significance of number 2? And each chapter, the kids just go through this historical, kind of satirical sometimes. But the point is to make numbers and mathematics fascinating to kids. I was hooked. Every time we went to the bookstore, I would look for basically the sequels of that book. Like I don't remember it now because it was in my language, it was translated or something. But it every time I would like, oh, I want to learn more because there's such a cool story, something that the kid then want. We all daydream to be able to get transported into somewhere cool. And at the time, it was like, the total solar eclipse was such a cool thing. It was crazy. People started war from it, and people they talk about it in terms of mathematics, and that really got me caught on like reading. And like right now, like I don't like reading that much
Yeah.
because we read all the time as a part of our job, right?
Yeah, exactly. I have all these books I need to read, and I just by the time I get home from work or finish work, it's like, oh, I've read all day. I don't want to read anymore.
Yeah, reading is, I mean, certainly a big part of our lives. And I also have my parents to thank for that, especially my dad for having so many books around that were, especially about history, because that's what he studied in university. And it was cool to see these books like a giant leather bound atlas or a 2,000-page book on the history of Egypt or things like that. And I think just that desire to read and learn more is really important in developing young minds to think more scientifically or more logically.
Yeah, I think kind of like the advantage of kid these days, where those books are like easily carried. I remember, in English you have dictionary, right? In Thai, the dictionary is much, much larger. It's like, let's say, like you can get the biggest English dictionary you can have. You double that width and double the dimension, and that's like our dictionary. It's like bigger than our bag. We didn't have to carry to school sometimes. It's like insane. So yeah, it wasn't that accessible, in terms of knowledge. So if you want to know something, you have to like, oh my, like find a new word. You have to pick up this big book, try to open it, learn how to index and find those terms and how to define it. And you want to learn about science, how you will learn it. There was no internet, or the internet wasn't as fruitful or complete as it is now in terms of knowledge. So you have to go to certain books, you have to ask people, you have to go to your teachers. And and to me that actually helped because you learn how to make effort to find information, not just find anything at your tips of your fingers. And it's kind of help mitigate the feeling of dread that comes from research. Like you have to spend a lot of time finding something so simple in research, try to solve this thing. Then you remember, oh right, when we were kids we have to solve these easiest problem by just like running around finding books, or try to open it, read every line, try to find where it is. But now it's so simple with the search engine and everything.
They used to have book fairs in elementary school, at least mine, and I'm sure this is a pretty common thing, at least in Canada. And yeah, I'd always be hyped about book fairs because, again, similar to you guys, books were kind of how I got into science, except I didn't really care about physics or math too much when I was in elementary school or when I was like grades primary to 7 or so. I like really liked animals and bugs and rocks and things. Like if you go back to my house in Nova Scotia and look at the bookshelf that's in my old room, it's just full of like animals and in like books about insects and books about like rocks and minerals and all kinds of stuff. So that was kind of those were my favorite things. And then later in my life, I decided math and physics, but I can talk about that later.
Yeah, I think my household had like a encyclopedia, right? Like theories of books about animals, plants, life, history, all those stuff. And I think that such a great thing to have in a book when raising children because like well when they're bored just pick one of them that's like filled with new knowledge that they haven't heard before. And like to me like I got into physics because it's the most fundamental of science, right? Like when I read to chemistry, I always ask questions like why does that happen? Why do we have these weird orbitals? Why do you have to SPDF? Why you have to do this? And it doesn't answer my question. Physics has answers to it. Maybe not a great answer sometimes, but it's more fundamental. You start to accept more axioms instead of theories, right? You can lead it back to the most fundamental understanding that human can have or human had at the time.
Yes, I remember grade 11 chemistry. I had a really, really good chemistry teacher. And he would always make this analogy that, you know how to drive a car, but don't necessarily need to know how to fix it or repair it. You just get someone else to do it, right? As long as you know how to drive, you're fine. And that's the way he described chemistry to us. I remember always being like, "What are these SPDF orbitals?" And he's like, "Doesn't matter. They exist, and you'll learn about it later if you pursue physics." And then I remember in physics we did like the hydrogen atom or something like that, and then you learn about like what all these numbers mean. Like you have, you break up your wave function to a radial part and a spherical harmonic part, and then I'm like, "Oh, all these numbers come out." So it was really, I thought that was so cool. And yeah, that's like, you don't do physics because you want to make billions of dollars, like the engineers do. You do it because you're like, what the hell are these SPDF things? And now there is the problem that we actually don't even understand quantum mechanics, but we're working on it.
So, Liam, would you say that your chemistry teacher was the reason you went into physics?
So I always like science, but I mentioned this. I really like kind of biology. Like I would always just spend my time as a kid like going and looking at bugs, and we'd go. Some of my friends we'd go catch frogs and put them back, and we got some frog eggs once, and we raised them and then put them back in the pond. And so I really like biology a lot. Um, and I didn't really like math. I was kind of bad at math for a long time, and then at some point in grade 8 or 9, I just remembered that we had this y equals mx plus b problem somewhere. I remember we used it to like model something in the real world, and I remember that like changed my life, and I suddenly really liked math. So it was around grade 9ish that I decided I liked math, and then I kind of just went with the flow. I just took like all the sciences I could in high school, and I took grade 11 physics, which was taught by an engineer, and I thought it was super cool. I liked Newton's laws a lot. I thought they were kind of neat. But yeah, this high school teacher I mentioned, he had a master's in chemistry, but he also taught physics. So he taught me chemistry and physics, and he was kind of the main reason I went into physics. I always knew I wanted science, and when this engineer taught me physics, I knew I really liked physics. But until that specific chemistry teacher, I kind of thought maybe I'll do math because I really liked math. I liked math a lot more than physics, but then this chemistry teacher kind of showed me that physics is really cool. And also I'm glad I went into physics because I say I like math, but what a mathematician like what a pure mathematician considers math, I absolutely hate. I hate proofs and all this pure math stuff. Like I respect it, like real analysis, but it's beyond me. I don't know how they do it.
Yeah, I think I have the like a similar notion too that when you learn math as a kid, you're like, oh, these are really cool theorem and stuff, and then you realize like, oh, this is some super roundabout way to prove it. Like it's like it makes sense. It's super logical. Like, but to me, it's like, well, it's true. It's true. You look at it, it's true. But rigorous proof are necessary, right? But I just don't like doing that at all. I realized early on that I'd rather go to like math competition, you solve problems so fun, than just like sit down and try to prove by really a rigid logical argument.
Yeah, I guess that's going back to driving the car without knowing how it works. It's fun to drive, but going into the nitty gritty mathematics is not as enjoyable as just doing it.
Yeah, pure math is it's something else because I remember we finished first year university, so we'd taken calculus and stuff, and I'd taken calculus in high school too. But it was nice to go through it in university. And then I remember looking at courses I wanted to take in my second year, and I was thinking about real analysis. I remember someone mentioning, they're like, oh, well, real analysis is just kind of like proving calculus. And I was like, what? Didn't we already do that in calculus? And they're like, no, 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 no. You did not prove calculus. You hand waved your way through calculus. Mathematically, rigorously proving it is a whole other thing. And I was like, oh my God, I could never.
So, talking about classes in our undergrad and just our undergrad in general, I know we all were in the same program, so we all did an honors in physics for a Bachelor of Science degree, but we all definitely had different experiences in our undergrad in terms of academics. So, what was that like for everyone just going through the undergrad?
So, to quickly summarize it, first year was pretty good because first year of university was just doing high school, like doing calculus, which I took in high school, doing physics, which I'd taken in high school. But in high school, we never used calculus in physics, so now this was physics with calculus. So that was fine because I knew physics and I knew calculus. And then at our university in Nova Scotia, we had to take all these extra art electives throughout our 4 years there, and I just pounded mine all out in the first year. So I took like an economics course. I took a Scottish Gaelic course and a Celtic history course because our undergrad university had those, and I play bagpipes, so I was like, well, why not? So it was a pretty chill year. I absolutely hated economics. I think I felt that was the first class I ever fell asleep in my life. And the first class I ever just actively skipped. Um, don't tell the profs, but uh, it was a pretty chill first year, and then second year was when things started to ramp up. Second year was for the first time in a while that we started to learn new things. It was like new physics, new math, stuff that I kind of had never seen before. I remember in mathematical physics they introduced the nabla symbol or the gradient operator, and I was like, oh, these triangles. I always wondered what those were. Second year was the roughest year for me, but it was probably one of the more fun ones because it was just all new stuff. And then third and fourth year were really fun because those were when you start to get into like you're getting into doing enough physics that you can kind of understand research a little bit now.
I remember falling asleep in almost all my classes except for the arts in first year. I fell asleep in physics, I in calculus, in earth science. I always sit at the front of the big lecture hall. The professor know, like they would see me nodding off. It's kind of hilarious.
Yeah, that's how I knew you because I don't know about Patrick, but me and my friend would sit somewhere in the back middle every class, and there was always this Asian guy at the front of the class who would just nod off every like few minutes, and the prof would like look at you like, and he'd kind of like shake his head and just continue on. It was so funny. And then yeah, in second year, I was like, oh, it's this guy.
But the thing is, I aced all the exams, so like, what are they gonna say? Like, maybe I just studied in my sleep. Like, I remember because like I think the awards for like a best student in physics were just like alternating between Liam Farrow and me. I was like, who is this Liam Farrow guy? It's like how I can see. It's like I think like I don't know. I think I did pretty well because like in all physics and math class, I get like
Oh yeah,
really good marks. I was like, Dang.
Yeah, no, you were fine sleeping through the classes. I had to stay awake and struggle through them, or else I wouldn't have did as well as I did. But that might be because of my high school education. Who knows?
Yeah, but to me, the second year was probably the best. Like you said, like we actually learned what a lot of symbols mean, and I really like my math phys class and classical. To me, one of the best courses I had. It's such a change of pace from the children physics to the big boy physics, and to me that was so fun. I had a great time. I killed all the exams. It was so great. I just had a good experience.
Yeah, second year was the roughest for me, but I'd say it was the most fun. It was the roughest for me in the sense that I did the worst. I think classical mechanics was one of my favorite classes. Um, and mathematical physics as well, like you said. But linear algebra, I think linear algebra was where I decided I hate pure math, because of all the proofs you had to do in it that just, in my eyes, seemed pointless. I was like, it's in the textbook. Someone here did it. Why do I have to do it again? You know, I can see it. I understand it. I shouldn't need to replicate it on a test. It's this like 3-page long proof about like why A plus B times C equals like A times C plus B times C. It was like, oh God. So linear algebra was the first midterm kind of test thing I'd ever failed in my life. And I remember getting that midterm back and being like, oh, I really gotta wisen up, because I was so like hyper focused on all the physics classes. I just didn't care about the math one. But yeah, it was so fun.
Yeah, I have to agree with you, Liam, that second year was also, I think, the roughest year for me. First year, it was like high school 2.0. A lot of the topics were similar to what you learn in high school. And I remember also in first year, I wasn't even sure what science I was going into. It was between biology and physics. Ended up going into physics. And second year, it was just a massive leap from what first year was. And I think my favorite class, potentially from all of my undergrad, was classical mechanics, just because it was so unique in what it taught. And we did get to learn a lot of those different symbols. And we really dive deep into, as our professor would say, just one equation. And that's all we needed to know. But it was definitely a very cool course. And there was also a lot of math in second year because we had to take so many math courses. And then for a majority of the physics courses that we took, they were also just, for the most part, pure math kind of thing.
Yeah, I don't know what it is about symbols in physics and math, but somehow whenever you're like introduced to something new, you get a big rush of drugs to your brain and it makes you feel all hyped about it. I don't know how that works, but that's how I felt in second year. I just felt like all these new things were coming at me and I was just excited the whole time about it, because I was kind of like, first year, like you said, is high school 2.0, and I was kind of bored by the end of it. So I was really hyped about second year.
Yeah, I think first year is so a lot about like being in university for the first time, right? The first year university experience, and our universities has a lot of cultures that we had to go through. So I think that's part kind of you kind of learn how to learn, right? How to actually learn by yourself, because professors are different from high school teacher. They don't come at you for like not handing a homework. They will just fail you. So I think there was that transition that you need to make, and that was good though. A lot of people struggle with it. I can see. Like I remember choosing my electives, and I was like, well, people have been telling me, my friends there, like just shoot what they call quote unquote bird courses. So those are the courses they can get grades easily and pass. To me, it's like, well, that's kind of not very useful, and tuition is expensive. I don't want to waste my time learning something I don't want to learn just for the grades. So I took English and philosophy, learned literature, learned philosophy, which kind of hurts my overall grades, right? Because you cannot have like 100 or like 95 plus in those classes. Just that's just not how it works. But it actually helped me out a lot. I would say like my favorite classes are not physics at all. Like they're those philosophy classes.
Well, my favorite classes were definitely physics ones, but yeah, it's interesting. Like, I don't know if I've ever met I don't know if any physics friends I have ever took bird courses. I don't know what it is about physicists, but they like to punish themselves. They like, if there's a course being offered that looks extremely hard and they don't need, they'll take it just because they're like, oh, that looks interesting. Like even next year, I think I'm taking a quantum electrodynamics class and a quantum field theory and curved space-time class. And I don't think I'll need either of those in the next 5 to 10 years of my life, but I'm just taking them because I'm like, oh, that sounds neat. And I don't know about other fields, but I definitely see that a lot in our field.
Well, a lot of people learn courses or knowledge in courses to do something, right? To get work, to get a job, to use it in their line of work. But a lot of physicists and pure scientists in general, we learn courses because we are curious about it, because we want to know what's going on. We want to know how these things work. If I want to learn quantum information, I want to learn it not because I would use it in my job, but because I want to know about quantum information formally.
So we are all definitely questing for knowledge, I would say, especially in our undergrad where, I mean, that's all we have to focus on is our courses. I know some of us had jobs, but for the most part, that was the nice thing about undergrad is you only had to really focus on your classes. But in our quest for knowledge, all three of us also did research during the summers. So what kinds of research did everyone do? Because I know for the most part, it's wildly different than what each of us are doing now.
So, yeah, undergrad research is interesting because you kind of just take what you can get most of the time. So, like, I remember you did some biology research at one point, Patrick, and then moved to physics eventually at some point. I'm not sure if you were just taking what you could get at the time, but I know I did when I started research. So I started research in after my second year. I remember I studied this thing called density functional theory, and I remember almost nothing about it. And then in my third to fourth year, I transitioned to another professor and did research in kind of quantum mechanics in accelerated relativistic reference frames. So it is kind of like you can do these weird jumps, like density functional theory is a lot of chemistry, and then I jumped to like kind of relativistic quantum mechanics over like a summer. I don't know how yours went or Feely's went.
Well, I was fortunate to being able to do research every summer. So after first year, after second year, after third year, so all summers. Because going home is expensive. So I was like, oh, I'd rather stay here and get a job. So I almost got, well, I was supposed to go tree planting. I already got the crew and everything. I was about to go, and then I got an email. It's like, oh, you want to come research? I'm like, sure. So I did some relativity research in my first year. It was quite nice, but it was like way over my head. It was like I just learned about calculus in first year physics, and now I'm doing some weird tensors stuff, which spend a lot of time not knowing. And then second year, I work basically with Liam, but Liam wasn't around in density functional theory and semi-classical physics. So I actually had a nice working environment with a collaborator from Algeria who came to visit. And then later on, I worked on water, which is thermodynamics of water, and basically water in negative pressure. So I get a kind of very rounded experience in terms of physics research in undergrad with like 3 supervisors, 3 summers. So that was super nice.
Yeah. So as Liam mentioned, after my first year, I did kind of take what I got or could get, and that wasn't a physics research position because at our school, there was not a lot of experimental physicists, and that's what I wanted to go into because I enjoy building stuff. So that didn't happen, so I ended up working with giant sea slugs out in BC, but with a professor from our old university. And that was, to be honest, one of my favorite research experiences and just a fantastic supervisor. The summer after, so that was after my first year. After my second year, I attempted to do physics research, but unfortunately that professor left halfway through the summer. So I ended up doing chemistry research and working in a chemistry lab to try and use graphene in essentially color changing glasses. So if you've ever seen smart glass where you can turn it off and on and it blocks out light. That's what I was working on. In my third year, I finally got into hardcore physics, and I was working on some particle physics, high energy particle physics analysis from an old experiment at the Stanford Linear Accelerator. And then I was also lucky enough to get a position after I graduated for a couple months working in kind of environmental physics, where we were determining the greenhouse effect potential of different types of fluorocarbons. So a very wide breadth of research for myself.
Yeah, I can see why you like other fields of research though, because like Liam and I, when we're in theoretical physics, the day by day job is to come to the office, stare at a paper or the screen, write something down, solve some equations, write something up, and just talk to your supervisor. It's kind of like, you know, kind of boring-ish in terms of like, you don't get to go out to see sea slugs, you don't get to go climb up cliffs or take a water sample or anything, right? It's a very kind of plain old research.
Yeah, I find with the theoretical stuff especially, it's very, very easy to get kind of stuck, if that makes sense. Like, you'll come in, I have a great time working from my office, and I'll get a crap load done in like the span of a week, but then I'll get stumped on something, and it'll take me like a month to figure that out. So it's like a month of staring at like one equation, and it's extremely frustrating and boring. But it's very satisfying when you get through it.
So for you two who transferred to masters again in theoretical / computational stuff and are continuing to do that work in a PhD, is that satisfaction what drove you to continue that type of work and to continue even further to, I guess, spend possibly up to 6 or 7 years on that subject?
Yeah, I think grad school is quite a different experience. I have relatively many more burnouts, maybe because of the COVID time too. But I just felt, I questioned my choice many times because you actually do real research where in undergrad our research is well defined. The supervisor has a goal that they want you to reach, and that's it. And the project is basically 3 months or 4 months, and that's it. But here now, it's like we are searching in the dark. We don't know we're gonna find anything, and it's your idea. You might spend the whole week solving something and found out that that's just fruitless. So there were those moments that make me question my choice, my career choice. Like right now, I'm questioning my choice. Like I have to write a paper, and I'm not doing that very well. I feel like, when in our undergrad and stuff, we it's more structured. You just pass exam, then you're considered doing well. But now, what is doing well? Everybody struggle. Everybody struggle to do research. So what is doing well?
Yeah, it's weird. It's like you have more time in grad school to do things, but somehow you have less, is what it feels like to me. And yeah, you burn out much faster, I find, because it's a lot of just kind of shooting in the dark and hoping for the best. And if you happen to get lucky, you could get a Nobel Prize in 40 years, and if you're not lucky, then well, you'll publish a paper that 4 people in the world will look at, and one of them might think like, oh, that's kind of neat, and then move on. I mean, those are extreme cases, but that's what it feels like.
Yeah, I remember I was taking like 2 courses in one semester in grad school, and my friend was like, "Oh, that's a lot." That's like, what? Because when we came from undergrad, we take like 5 courses a semester and stuff. And I remember like 2 courses, and then I took like 1, and I was like, "Wow, it's not just a lot of work, but it's like intellectually tiring because it's much more advanced concept. You have to be, yeah, much more involved in your thinking. You have to think of it all the time. When you come back home, the assignments are much more exhausting. And I don't know if I can say now it is worth it. When sometimes when you're in the process, it's hard to judge what what you feel about it. You just in the moment. Like I don't know. I know that I like what I do. I like explaining to people. I like teaching a lot, but I'm not super 100% sure. I like my research, of course, but there's a part of me that's like, wow, the effort you put in doesn't translate to the basically the amount of quote unquote success, or those, the feeling of completeness that you get, because it's just a different type of career.
Yeah, I completely agree. It's very much like I love what I do, but you definitely question it at times, and kind of when you're in grad school, it's more like real life. It's not like, an undergraduate degree where people are kind of, well, I say you get babied in an undergraduate degree. You do to some extent. You're at a university, you're on a campus, you have like a meal hall, you have a bunch of friends and stuff, and you move to some random city that you've never been to do your graduate degree. And I've definitely questioned it before. Like, I really like what I do, but it's hard to say if I would change things or if I do it slightly differently, because especially, now that you're out, during your graduate degree, you've got bills to pay, and you see all these other people going and making tons of money, and then grad students get paid almost nothing. It's criminal, and it makes me jealous for sure.
Yeah, it's certainly a way of life. And I think from undergrad, we experience that where it envelops our lives and really it takes control, takes over. A lot of our time is spent either working or, if not working, thinking about what we're working on. I know there's a better push now for mental health and getting that work-life balance, but trying to describe to people who don't do science for a living, who don't do research and go through the woes and the successes, it's a challenge to try and put that in terms of other jobs, because yes, other jobs, you certainly have your woes and successes, but it's definitely different. Whereas like some jobs, most jobs, I imagine, you don't spend a year or two trying to figure something out and then maybe not even having a result. And I think that's a cool thing about science that keeps us motivated and driven, but also a drawback is the fact that our job is never really done. So no matter if you're researching some weird quantum mechanics topic or looking at forest from space or trying to figure out how battleships work or black holes or anything like that, there's always more questions that you produce, which is hard to explain to people that you're never quite done.
Yeah, there are no set milestones that to judge you, like, oh, you complete the project, the project can be very long. I think the important part going through this is your supervisor, or advisor. Like, my supervisor was very helpful, is still very helpful, and everything, like providing me perspective, great advices, and make me realize like the nature of the work we go into, that, it might you might feel a bit frustrating, you might feel defeated, but that's part of the job. Like, it's actually like you're not supposed to find out the answer right away. It's not like undergrad research, which is like the answer are just right there. You need to do some work to get it. But now you actually have to walk around, find the answers, and most people don't find the answers. That's why this is so difficult. That's why it takes 4 years for a PhD to maybe publish 1 or 2 papers. And that's such, to me, like, one of the good advice that he gave me was, this is a part of what we do. Is part of research. And if you think that research is something else, you just, not in the right mind, because it's not even, wouldn't say it's the con of it. To me, it's actually the feature. It's not a bug, it's a feature, that you're going through this frustration, because to me, sometimes in life, you can't appreciate those frustrations. It makes you realize that we are doing difficult and meaningful work because it frustrates you, it challenges you, it hurts you. So, it might be a strange perspective, but it helps to keep you going, basically. And one of the most important thing is to keep going, right? Because if you stop, people stop, people burn out, people dropped out. But to continue in this is just, there are not that many ways to do it. Yeah.
Yeah, it's certainly a different way of thought and a way of life. I think with that, It's a message for people that keep being intrigued by the world, keep asking questions, and really think about what you're seeing and what you're doing. And that's from a science and non-science perspective. And with that, I think this is a good place to perhaps wrap up.
Yeah, I think I could make a closing remarks because when we had an idea of doing this podcast and talking about the world and physics, it was just very casual and we didn't think much about it. And then I just decided, you know what, let's do this for real. So this has been a journey for me. Like it is really stimulating to actually talk about these to people who care. And I appreciate us all that we do this, you two coming and join, and it's a decent amount of work to put this together. So, and I'd like to thank the audience that follow us to the journey of the first season. We have learned a lot about things, new things for us, and hopefully for you guys. And yeah, so I think this is gonna be the final season of the episode. We will be back hopefully sometime next month, in September, probably mid-September at some point. But yeah, it's been great, and this will be a good place to stop. So I hope to see you guys later on, and see Liam next week.
Yeah, it's been fun.
All right.
See ya.
Take care.
Bye, everyone.